Hello! In this exercise we're going to be taking a look at the use of a sniffer and in particular just how powerful a sniffer can be. This exercise is actually broken into two different pieces because there are two main points that we're trying to make in the discussion. The first is just looking at a sniffer, seeing how powerful it is and the kinds of things you can see. The second is illustrating an activity that's quite useful for network and system and security engineers to perform periodically. Let's get started just looking at the demonstration of what a sniffer can actually do. So here on my computer, I've got a copy of the USB stick for the class in this folder, 512 USB. Inside of that, in the Day 1 folder, I also have an installer for Wireshark. Now I'm going to get that running, and while it's running, we'll just talk about it a little bit. As is mentioned in the class and in the course book, this isn't something that you personally need to be able to do. We really don't expect a security manager to run a sniffer, but certainly you should be familiar with what one is, the kinds of things that can be done, and if you are feeling a little bit more curious, you are welcome to reproduce exactly what we're doing here, which is the reason why we've recorded all of these as videos instead of just having the in-class demonstrations. In this way, you can just follow along with exactly the steps we follow here. The sniffer that we're using is a very widely known and quite popular sniffer. In some ways, the power of this particular sniffer has changed the way that sniffers are sold and marketed. It used to be that sniffers, at least quality sniffers, were quite expensive. But this community project, which started out as a tool named Ethereal or Etherreal, later migrated into Wireshark. It built on some work that was done previously with the Berkeley Packet Capture Library and TCP dump. Now, this actually completely replaces TCP dump, but it does still use PCAP, that Packet Capture Library, and has become more or less the standard for sniffers today. Now that I have that installed, I'm just going to go back into the Day 1 folder, and you may notice that the icon here has changed. It's now showing the actual icon for Wireshark. Now I could go through the sniffer to get to this, but it's actually easier to just double-click and open up the packet capture. Once that's done, let me just make this a bit bigger, and I'm going to skip the updates for us. All right, let's take a look at exactly what it is that we're seeing. Just reorganize the windows a little bit. The top part of the display here is, in a sense, showing me a network view. It's all of the packets that have been seen by this sniffer. Now the sniffer that I've run here was just run on a part of our internal network and just captured data for several minutes. There's also some interesting activity inside of this capture that we want to illustrate in showing the kinds of things that you can see and the kinds of things you can't see. So that top view is what's happening on the network, but if I were to click on something in here, perhaps this packet here, you notice that the middle window changes. In the center window now, I can see the layer breakdown of the individual packet, and if I break these open, I can then see all of the different fields that are found inside of these headers. Now these headers will be talked about in Day 2 to some degree when we take a look at the kinds of things a network engineer or a security engineer might know, and also discuss how perhaps we might interview that person and the kinds of expertise we might expect them to have. Down at the bottom, however, we're seeing the actual raw hexadecimal. This is the actual packet that was captured, and if I click on different fields here, you'll see that it highlights that within the packet at the bottom. In this way, I can identify exactly what's happening. Now, for us as managers, I do not need to be able to do that, nor do I need to be able to read that hexadecimal. But instead, we just want to show you some of the interesting things that you can find with a sniffer and see how easy it is to actually see some of this data. I notice, for instance, that in this particular packet capture, right here, I see something involving port 80. And from my knowledge, I know that port 80 is used for web traffic. Let's see what kind of web traffic is happening. So if I were to right-click on that packet, for instance, I could choose to follow that conversation. Let me try that. And I don't actually expect to see a lot here because I'm actually picking that up at the very end of the conversation. And it shows me there's no content. Inside of the other screen, though, you'll see that it has automatically filtered the data down, so it is only showing me that very first stream. Let me clear that filter. Let's try that again. This time, I think what I'll do is search for tcp.port equal to port 80. Now, there's actually a wizard that can be used to create filters and search for things, but to speed our lab up, speed up our demonstration, there's really no need for us to go that far because we're not trying to teach you how to use a sniffer. However, by doing this, adding this filter, it reduces what I see in the main window here. And you may be able to see for yourself right here, you can actually read that there's some kind of request. Now, in our material on secure communications, we're also going to take a look at how web traffic functions. So we're not going to get very deeply into this right now, but let's try to follow that stream instead. Now when I do that, you see that there are two sections to this. Part of it is in red, and part of it is in blue. The red is showing the data that was sent from the client to the server. In this case, you can see there was a request to get the main page, the root, the index, apparently out of a website named grocklaw.net. The blue, though, is showing me all of the data that went from the server back to the client. And what we're looking at right here is the actual web page. So even though this data was sent over many different packets, this tool is automatically reassembling the entire thing so that I can view all 84K of data at the same time as data rather than as individual packets. Now that's a very powerful thing. Let's, though, look at a couple of other kinds of traffic that might be interesting to find. Now, as we look at these, some you may expect to find on a network, some you might not. For instance, if I look for tcp.port equal to 23, I would be looking for telnet traffic. You really do not expect to find telnet traffic on your network, but in this particular packet capture, we do have it. And just because you don't expect to find it, doesn't mean that you won't. I still run into organizations where some servers, especially core servers running Unix, are still being managed by administrators remotely using Telnet because they don't feel like there's any real risk doing this on the inside network. But what's the impact of doing it? Let me follow this stream. And when I do, you can see here, well, let's see, some of the data is doubled. And if you look closely, you can see that it's red, blue, red, blue, red, blue. What's happening is the user is typing a command, show users, and it's echoing each character back. And then it's echoing back or giving you the output of that. And we can see the results of everything that this user typed. Now, it's clear text. Clearly that's bad. Let's, though, take a look at this another way and illustrate perhaps why it could be so bad. I know that this telnet stream, if I look at the bottom of it, ends about 43 seconds, 43.7 seconds into the communication or into the packet capture at packet 5432. Let me clear that, and let's again look at tcp.port equal to 23. Now let's see, 5432 I think we were, or 47 seconds in, that sounds about right. Let's see if there's some telnet after that. And it looks like there is. Let's follow this stream too. Now this, perhaps, illustrates more directly what the real risk is. Here we can see a successful connection to this system. We see a user trying to log on and what his password is. And he fails. He logs on again and fails, and then logs on and he succeeds. He's forced to change his password, so this one's no good anymore. But you can see as well that we can see the new password that has been created too. This is just an illustration of why plain text protocols for management of systems is so bad. We absolutely should not have that kind of activity happening within our network, especially for the administration of systems. There are some other kinds of traffic here. For instance, let's also look at something that you will find on your network, especially on the external portion of your network, where clear text could again be interesting. TCP port 25. Now you may know that port 25 is used for mail traffic. I'm going to follow the stream. And in this case, we don't have an actual successful email connection. Oh, well, actually, let's try a different one. This one tells us simply, you're not allowed to connect. So that's just an outright refusal. Let's look for a different one that starts after 633.87. So let's change this to TCP port equal to 25. So after 633.87, let's try this one here. All right. And we can see how a mail server would talk to another mail server. In this case, the mail is not actually being delivered. We can see that the email is being refused by the server. It's saying, your address is known to be a bad address. That's good. It shows that we have some defense there. But we can also see that all of the content is actually in clear text. And this is quite common. What we tend to do is use encrypted protocols between our workstations and our servers, especially if we're using remote email, in order to access the data, to retrieve the email. But from our mail server to another company's mail server, that data is typically not encrypted. That means that it's sent in clear text, just like this. This is why in our Secure Communications Day, we're going to discuss email encryption solutions and why that's so important. Let's look at one more thing. Let's look at tcp.port equal to 22, which would be secure shell traffic, and let's just compare that to what we saw with Telnet. Let's follow that stream as well. And in this case, while I can see the initial connection, this is part of the initial header where they're doing negotiation on what kind of authentication to use and how we're going to sign things. And in the end, they select to use RSA, which for right now we don't need to understand, but we'll know what those things are and perhaps call these things back to mind as we discuss these matters on the Secure Communications Day. But you can see further down here the actual communication, where the management's happening. And it is completely unreadable. So when we use encrypted protocols, even though some portion of it may be readable, the data itself is what's being protected. Well, that's what a sniffer is and how powerful it is. We're going to stop here for now, and we'll take a look at part 2 and take a look at the kind of exercise we might expect an administrator to conduct periodically.